So in this video, welcome to a new video for Schlumberger Academy. Today we are speaking about the Boreal electrical images, and the Boreal electrical image is the logs used to measure resistivity and conductivity of formation around the Boreal using electrical current. We are different type of logs for make measurements of resistivity logs, like lateral log, or also lateral log like LLD or LSD. This kind of logs are focused on flushed and unflushed zone in conductivity mud system. So for the determine the clay volume essentially. Induction log using non-conduction mud, measure magnetic introduction response, micro-resistivity logs, help response invasion zone near Boreal walls, and focus on resistivity logs. High vertical resolution, can distinguish between thin beds and laminated, and so we have also other application. These tools generated by 2D or pseudo 3D image and of the Boreal wall by measuring micro resistivity with pad mounted electrodes. Full bore formation micro image, in this case is released directly by Schlumberger. We have a series of patents in this kind of micro electrical image. But today we want especially talk about also with why we do, for example, electrical Boreal image instead, for example, gamma ray, because the conductivity and the parameter that are measuring with the electrical image can make an impressive idea also of how many gas and petroleum system can be moved from the single zone. So we have a serious application like identify open and closed fracture with underline deep and azimuth plot of fracture, of system of fracture, bending planes, structure deep analysis, stratigraphy paleocurrent, detect displacement full zone, grain structure, cross bending, and bioturbation. Breakout also Boreal stability and in situ stress. So the second part that I view in next video is how acquire data and make processing for the Boreal electrical image that are enveloped in a cylindrical view. Tools to apply for have a depth shift correction, noise filtering, and color normalization. So generally we have this kind of type of results. So we have the application for structure, for structure deep, for detection, structure description, in situ stress, correlation, and also geosteering operation. Facies analysis, forces trace analysis, tensional environment, paleocurrents, sand buoy geometry, sequence stratigraphy, and else we have a petrophysical application like net, sands, permeability, heterogeneities, flow buffers, into reservoir models, for example in textures analysis like this. And also we have a great application in sedimentology like identification of paleocurrent or sand body geometry, deposition environment, and sequence sequence stratigraphy to make reconstruction of the evolution of the area. So today we are speak about these particular logs that are the lateral electrical image, lateral logs LLD and LSD, that are the oldest kind of type of logs. LLD is a lateral right and LSD is right or left. So we have this scheme for underline, which is the kind of acquisition and make the interpretation of zone. Generally make in mud zone with just mixing zone with fluids and gas. So we have a flashed zone in this case, zone of transition, and we have a receiver and transmitter. We make this relevation. We elevate especially water saturation in zone and resistivity of water in this zone. This is the first example of lateral logs LLD. I make zoom in this case. Lateral log shot free, this make in Norway. We have this. We have a first part make with caliper and second part make with lateral log to measure also resistivity and conductivity. Only in a side of well bore. This is the characteristics of lateral logs. LS log, so which are the application. The LLD provides several key benefits. Wellbore trajectory mapping is used to make trajectory mapping during drilling. It creates detailed maps on well path. It's very crucial to understanding how the wellbore intersect the different geological formation. So it's essentially used also in process of formation evaluation by analyzing the well trajectory and find a potential hydrocarbon reservoir and a spatial relationship. Is also important for drilling optimization. LLD data helps in planning future drilling operation and ensure wells are drilled in the most efficient and productive manner. Production optimization, understanding the wellbore trajectory, allow for better placement of production equipment and its recovery rates. Deep lateral resistivity is specialized LLD technique that use a lateral log probe to measure the resistivity of formation in wellbore surrounding. Is especially used to identify the fine beds. Lateral logs probe can penetrate deeper in the formation and allowing the detection of the presence of hydrocarbon. For optimize production is when we have just finished the drilling and we have made the computation to start production and optimize production. This is really accurate kind of log that can be characterized the reservoir properties. Also, for example, the change in vertical or horizontal porosity. Analyze complex formation. The deeper penetration capability of lateral logs helps difference between different and type of formation. In conclusion, LLD log serves very vital tools for oil and gas exploration and production, and it provides critical information about the wellbore's trajectory, formation properties, and potential hydrocarbon resource. So is an oldest technique, but is still using in this case to optimize the production and make some characteristic information evaluation. LS log is another type of lateral log. Is referred to a critical technique employed to understand the subsurface geology and hydrocarbon reservoir. Lateral shallow log, LL mean lateral shallow logs, is a type of resistivity log. Shallow lateral log resistivity is focused on measuring the electrical resistance of rock close to the wellbore wall, inside the wellbore wall. This technique is particularly useful, for example, for identifying thin or high resistivity layers. The layer often represent a variable hydrocarbon reservoir, or distinguish between conductivity formation. Shallow lateral can difference between formation with varying electrical conductivity. Mapping the distribution of hydrocarbon, the resistivity measurements help locate and map the extent of hydrocarbon deposit. Improved resolution, benefits of shallow lateral log, improved resolution. The shallow measurement provides high resolution that can be compared to traditional resistivity logs, and also can make precise mapping. The detailed data collected through shallow lateral log allows for accurate mapping of hydrocarbon zone and potential reservoir boundaries. Reservoir characterization, it helps access the porosity, permeability and fluid saturation of potential hydrocarbon reservoir. Well planning, the data obtained from shallow lateral logs, decision regarding well placement, drilling strategy and complex technique allows to well planning drilling, and in some cases also use in production optimization. But I think the most underlying difference between LD and LSD, lateral log, shallow lateral log resistivity, is that the first LD is used principal for wellbore trajectory and during drilling and formation evaluation, and in much more case for drilling optimization. LSD is especially focused on some particular case, for example, when we have high detective formation with resistivity. So it's only focused on some events during drilling and mapping the distribution of hydrocarbon. Much more less in second phase, when we are the completion phase and all else. So in conclusion, lateral log shallow is vital, is essential in oil and gas and geothermal industry to provide valuable information about the subsurface formation during the drilling of high resistivity geological area. These techniques play a significant role in identify and characterize the development hydrocarbon reservoir, unlimited contribute to efficient and unexpected exploration, production, energy. Thanks for attention.